Okay, everybody, the first thing we're going to talk about tonight is um, what we consider to be work problems, which basically means that either one person or another person can do some sort of an activity in a certain amount of time, but then if we were to do that activity together, we could find out how long that same activity would take as a group. So as you see here on the screen, I have a gentleman over here filling a pothole. His name's Billy, and it takes him 45 minutes to fill 10 potholes. At the same time, you have his friend Jimmy over here. It takes him 45 minutes to fill 10 potholes. So the question is, what happens if they were to fill those 10 potholes together? How long would it take? Luckily, we have this excuse me, we have a little formula that can help us with this. It's kind of called the work formula, but not really. I just kind of call it that. But the way it's going to look is this. We're going to put a T over A, and I'll tell you what these things mean in a minute, and we're going to add that to T over B, okay? And together, that's going to equal 1. All right. Now, right now, that probably just looks like a bunch of variables inside a box for you, and I understand that. So let's kind of identify what these variables are. For the letter T, okay, the letter T stands for the time to complete the job together, okay, as a group or as a pair. Okay, that's what T stands for. The A is going to stand for um, the first person and their time. Okay, so the time that it takes the first person. Okay, and then the B is going to just stand for the second person's time. All right, now in our particular situation here, if we go ahead and just go back a slide and we look, the first person is going to be Billy, and it took him 45 minutes. Okay, and the second person is Jimmy. And actually, you know what? I'm going to switch this to a 55. That's a little typo there. We don't want them to be the same. I'm going to switch that to 55. Sorry about that. So Jimmy is going to take 55 minutes. All right. So as we go back here to the next slide, for our specific example here, A is going to be 45, which is Jimmy's time, and B is going to be 55. Okay, so we're going to take these and we're going to substitute them in here and here, and when we do that, we're going to have an opportunity to solve for the T. That's our goal here. Okay, so as I extend this down here, now this is going to look like this. It's going to be T over 45 plus T over 55 equals 1, with the goal being solving for T. We want to know what would be the time if they completed this together. So at this point, it just comes back to solving a rational equation. Okay, I would want to multiply both numerator or all the numerators by 45 in order to get the 45 to cancel out of the fraction. And I would probably also want to multiply all the numerators by 55 because that would cancel out the 55 that's in the second denominator. Now you could take the time here to find a lowest common denominator, but honestly in a case like this that might take a little while, and I'd prefer rather than to just do it this way. 45's cancel, 55's cancel, and now my fractions are gone. So I'm going to bring down this plus sign and my equal sign. In the first part here, I have a 55 times t left in the numerator. Okay, so that's going to be 55t. And in the second part there, I have a 45 and a t left in the numerator. If I multiply those together, that's just 45t. Okay, and on the right side of the equation here, I have 45 or 1 times 45 times 55. Well, I'm going to grab my handy dandy calculator here real quick, and 45 times 55 according to my calculator is 2,475. Okay, now we have enabled ourselves to get rid of the fractions, and now it's time to go ahead and solve this thing. So these are like terms on the same side of the equal sign. So 45 plus 55 is 100, and on this side over here I have 2,475 still. And now I'm going to go ahead and I'm going to divide each side by 100 so that I know what that time is that it takes them to complete this, to fill in 10 potholes together. And that time is 24.75 minutes. Now, for the sake of, layman's terms here, we don't usually talk about minutes as decimals. Okay, we talk about minutes and seconds. So the question kind of becomes, okay, how many seconds is 0.75 of 1 minute? Well, you can think of it as 3/4 of a minute, okay? Or if you want to do 0.75 times 60 seconds, which is how many seconds there are in a minute, okay, that would give you 45. Okay, so really what you have is 24 minutes and 45 seconds. Okay, and that's how we solve a work problem. So let's go ahead and let's do one more example here. I'm already 6.5 minutes in here. So what if there's 3 people? We have Miss McLaren. She can cut out triangles in 30. She can do 30 in 30 minutes. Of course, I can do them a little faster. I can do 30 triangles in 20 minutes. And Mrs. Reed, well, it actually takes her an hour to cut 30 triangles. The question is, how long would it take if they, typo, let's change that real quick, that'll bother me. If they cut the triangles together, okay? So the only way this one's going to be different is that I'm going to have 1 over, I'm sorry, not 1. Let me go back here. Cut that out of there. Whoops. Okay. Instead of using only t over a plus t over b, now I have a third person, so I'm also going to have to introduce t over c. And all 3 of those together, the question is, if you put them all together, how long would it take to do that one job? So, in this case, my A is going to be 1 person, my B is going to be another person, and then the C is going to be yet a third person. Okay? So, here's what we're going to do. 30 minutes for Miss McLaren, that means I'm going to do t over 30. 20 minutes for me, Mr. Cullen, that's going to be t over 20. And then 1 hour for Mrs. Reed. Well, I don't want to put t over 1, because then I have minutes, and then an hour. Okay, I want them all to be in terms of minutes. So I'm not going to use a 1 here. 1 hour I know is 60 minutes. So you need to make sure you use common units of measurement. Okay? So now it just comes down to finding a way to solve this. Okay, now it wouldn't be a very, I mean, you could, go ahead and multiply the tops all by 30 and then multiply them all by 20 and multiply them all by 60. But if I think about this a little further, if I just multiply them all by 60, 60 will reduce with the 30 and 60 will reduce with the 20. Okay, so I'm just going to multiply everything by 60. Okay, in the first part here, I have a 30 and a 60 in the top. Well, 30 goes into 30 once, 30 goes into 60 twice, and now in my numerator I just have 2t. Plus, second part here, 20 goes into 20 once, 20 goes into 60 3 times, and this is now 3t. In my third part, 60 over 60 cancels, and I just have a 1t. And then over here I have a 60. Well, if I do 2t's plus 3t's plus 1t, that's 6t's equals 60. Divide each side by 6, and t equals 10. If at any point from this video you need to stop, go back, rewind, go over it again, please feel free. That's it for tonight. We'll work on some of these tomorrow morning in class. Thanks so much.